Hello, it's Duncan. We left the last episode having implemented DeleteItems, at least the happy path, and with just one wafer-thin to-do left in the code. As you will see, it turns out that wafer is covering a hole that I'm about to fall into. Once in that hole, I carry on digging, finding problems with our test code that we hadn't noticed before, and our yak is quite bald before we finally emerge. Even then, it turns out we won't have solved the initial problem. Now, what about the other that was in app, where we said to do single transaction? This, I think, may take a bit of thinking about. At the moment, we're calling stock list now that runs items in transaction. And then we're running items in transaction, item saved. Now, I think that we might get away with putting a transaction around all of these and having stock list now, this transaction. I think it would be usual in these cases for the transactional code to say, do I already have a transaction? If I do, I want to run in the transaction that's there already. Otherwise, we'd have to make this function require a transaction. And that would complicate our testing code if nothing else. So let's go back here and we'll try and move this items in transaction all the way around here, like that. Just check the test to pass. Well, that's good, but we have to remember our unit tests only actually work with an in-memory database. This leads to the moral question of whether we need to add tests for all of our transactionality that use Duke for all of this sort of stuff. I think I'm going to say no, but maybe we should at least go to our DeleteItems here and create ourselves a fixture that uses Duke and just see what happens. So I'm going to go to this fixture, and at the moment the fixture creates its own items. I think we might be able to move this bit into the constructor and say that this is any implementation of items. We want this one, and we want to say of some sort of transaction context. And now instead of apply, I think in init, we can populate the priced items that we've been given. So we'll do this in our init with unpriced items. And then I think if we get rid of this, it will all compile. It will. And this was transactionally to allow us to drop the second receiver. Okay, does that still work? Bar a comma. And here we have to give the name price stock list. Build again. And the same thing here. Okay, now run the tests. And something is broken. What's that? Interesting. We don't have to see NullPointerException in Kotlin, so we must have broken it pretty badly. It looks like here we're calling invoke and our in-memory items appears to be null. Is that true? Here. And where does that come from? It comes from our fixture in init. In fact, so we're failing in init. Why is that? And the answer is that we don't yet have a stock list. We're saving the stock list, which is the unpriced one, but that's only been initialized down here. I think we can probably solve that problem by moving this val into here. Does that fix things? Yes, it does. And it's interesting that we very rarely seem to come across those issues, but the compiler wasn't able to tell us that we had a problem. Okay, I think maybe we should refactor this in order to change the order of these, and that way where we call it, we now needn't specify the parameter. Check that. Good. And now we wanted to try running our DeleteItems tests with the database items that uses Duke. So we go back here, and now here, maybe just temporarily, we can say that we want DB items based on test DSL context. Does that run? It does not. Let's go and see the error. And I really don't know why. Seems that we haven't saved any items. I tried running just one of these tests, the easy one, which is this one, and that still fails. But in a different way this time. I wonder whether our issue is we need to be clearing the database. Let's remind ourselves how to do that. That's in DB items tests. And as we're seeing, everything becomes more complicated as soon as we start using an actual database. But we'll suck it up for now. Back here, in this test, we'll do that and just see whether that makes things run. Still no. And there's a telltale here of no item saved. This is not an item. That was our marker for an empty stock list. Now I think we're digging ourselves even deeper into this hole, because the fixture is populating the items in its init, which is saving to the database. But our test is clearing the database before it runs every test, and that will be after the fixture has populated it. So we'll have to go to fixture, and I think we'll change this from an init into a function called init. And that way, in our DeleteItems test, we can say truncate everything and then ask the fixture to init. Does that work? And still not. And now we have something that looks very plausible, but the difference is that in one case we have a price of null, which means we never tried to fetch it. And in the other case we have a price with success of value of null, which means we did try and fetch the price and we got a null back. Now this is all pointing in the direction that it might be better to have a type of priced item than this confusion. But how are we in this mess at runtime? Let's look at our fixture again. And I think the issue here is this with price null. This with price null doesn't do what I expected it to do. It sets the price to be a success of price. If we pass in null here, we get a success of null rather than a null that I thought. What a tangled web we weave. And thinking it through, all this has really happened because our in-memory items, which is here, when we save a stock list, it just persisted in memory, but those stock list items will keep the price with them, whereas all other forms of saving lose the price. I think this is another case where we should revert, fix the root cause of the problem, and then re-implement what we have on top of that. So let's go to our commit, and let's take all these changes and we will shelve them. And that's just work in progress. Okay, and now I'm going to check that everything does work as it was. Oh, we need to run all tests. That's good. And now we need to fix in-memory items. Before we do that, we've got a contract for all of our items. Let's go to that. It's item contract. And let's write ourselves a test for that behavior because we want to see that all of our items do the same thing. So I think we'll go to returns last saved stock list, duplicate that, and this is doesn't save prices. So now we can take out that, I think, and say a stock list with prices is our initial stock list copy, where the items is initial stock list items map it with price. And we'll put some sort of price in here. Let's say 100 things. Need to import that and that. Now we're going to save the stock list with prices. But when we get it back, we expect to see the initial stock list. We think that's behavior of our database and our tab separated items. Let's see whether that's true. And we have two failures, the dual items tests and the in-memory tests. Well, it's not surprising the dual items test has failed because it was using the in-memory items. So let's go to our in-memory items and fix that. So when we're saving, we may be given a stock list, but we want the stock list without prices. And what does without prices mean? Well, we can create an extension function just in here, which is going to return this copy items equals items map. And then we want to take the item and the item copy price equals null. That's a single expression. And let's see whether that makes everything pass. It does not. I'm getting a bit tired now. Now our list stock test expected items with prices and is now getting items without prices. Let's see why. That I think is now reflecting our bug in our fixture. So in fixture, we have this problem. This isn't actually setting the price to be null. It's setting it to result with null in it. So again, here we want to say copy price equals null. Still a failing test. Do we do that anywhere else? Yes, we do. We do it here. So that problem has been pervasive and we only found it accidentally. Because we're looking in here for an item with the same properties except the price, we need to remove the price in the same way. So we'll do that. And that's just it in here. Does that finally pass? Yes, it does. I think given the confusion, I'm going to undo that, go to wherever with price is, and rename that to be with price result. And I think the other one could also be the same. And now let's add in here with no price. So that would be this, copy price equals null. And now going back here, we can say that this is item to item with no price. This will be with no price. And we can do the same in in-memory items here, item with no price. In fact, this stock list without prices looks like it might be handy for us as well. So I'm going to take that to make it more public, take it out of here, and put it wherever we were last in test data. So we've got stock list with items and we have stock list without prices. We can import that into there and also our fixture. So this is price stock list without prices. Is all that true? Good. Looking at this fixture, this confusion has been caused by us initializing it with a price stock list. I think maybe a map of items to prices would have been better. Maybe we'll try that another time. In the meantime, tighten that up. Okay, so we think we've addressed the root cause of our issue, which was in-memory items remembering prices. Let's commit that as make sure items implementations don't persist prices. We have one thing we should check, and that is still our work in progress. Okay, now we have the changes on that shelf to apply, and it was this one here. Looking at this, it seems we haven't even committed DeleteItems tests, so I'm really wishing that we had committed the thing that was actually working, albeit with 2 transactions, before we decided to address a to-do that turns out to have been a complete rabbit hole. Well, lesson learned. We're now faced with what may be a bit of a hairy merge, or making these changes from scratch. I think I'm getting tired and it would be very easy to mess this up. So I think this is a good place to end this session, and we can come back with fresh eyes next time and decide the best way to go forwards. Well, if you pay any attention to what I look like in the picture top right there, you'll see that this is in fact a different day. So let's see if we can get this merge over and done with. We'll go to the shelf and we will unshelve everything. And as these things are often quite difficult, I tend to not remove successfully applied files from the shelf. So let's do that. And here we have a conflict in fixture. Let's just see how well the magic wand does. The answer is, well, it doesn't compile, but let's have a look. Oh, that's a really horrible mess. I think I'm just going to accept right and fix things up. And now we can try and run the tests and see whether we get anywhere. And maybe unsurprisingly, that hasn't built, but we remember that we made a couple of changes. We made this with price null. That's this thing. And there may be some more in here, or lots of them. This was with no price. So that would have helped a bit. And then find these with price, I think were with price results. So if we find all the others of those, and we can say with price result. See whether that builds. Okay, a few more of those issues. So again, we have this thing is with no price. Build again. Oh, and it looks like we might be getting close. Run the tests. And now we have, let's have a look, a failure in DeleteItems tests and list stock tests. Let's have a look at the top one. That is a sell by date of null in our DeleteItems tests, and list stock tests. List stock has gone a bit weird. I think in DeleteItems tests, now it's using DB items. I think the database tests may be trampling on each other. We had a solution to that problem, and it was yet another JUnit annotation, which is resource lock. And if we look for that elsewhere in our code base, you'll see we used resource lock database so that JUnit can run in parallel, but not run the database tests in parallel. So we put that in there and see that we only have one failing test now, and that's list stock. Let's have a look at that. Now, we haven't made any changes to that, but we have made a change to the fixture it uses so that we now have to call init on it. So we can say apply init. And I think that might get us running. Do we use the fixture anywhere else? We do not there. So I think that we're finally good. Okay. I am finally going to commit DeleteItems tests. I'm not saying we're done, but we know that this DeleteItems work is hidden behind a feature flag. So it's all pretty safe to go to production, even though we haven't finished it. So I'm going to commit that as work in progress on DeleteItems. And now finally we have a checkpoint that we can go back to if we mess up again. Okay, so having fought off a number of alligators, can we remember which swamp it is we're trying to drain? We've gone quite a way with DeleteItems in that it's largely working, but the question we were trying to answer was, when we call DeleteItems with ID, and this runs in a transaction here, how many transactions are actually started in Duke? Because we've got this transaction here, but then listing the stock list has another transaction. So are we running one transaction, two transactions, a nested transaction, or what? Bearing in mind that what we actually want is just a single transaction. That effectively items in transaction should be in new or existing transaction. How can we find out? Well, a little bit of research shows that Duke has an instrumentation layer, and we can tap into that. And we do that by modifying our DSL context. So the DSL context we're using here is our test DSL context, but I'm going to create a different one. So I'm going to say val instrumented DSL context is our test DSL context. And now there's a Stack Overflow answer from Lucas that suggests that we can create a default transaction listener, and then we take the configuration from the context, derive it, and then remake a DSL. Okay, so let's remember the transaction listener bit. Go back. And now here we're going to say configuration, derive with a transaction listener, and then recreate a DSL from that. Our transaction listener will create an object, maybe just in this file, and it is going to implement transaction listener from Duke. And let's have a look at that. And we'll see it has begin, start, commit end, rollback start, a whole bunch of methods around the transaction lifecycle. So let's go into here and we'll say we want to override methods. We want to override all of these. And I think we might get away with saying, if I go to super and then say instead println, we might be able to do that, go to the end, go back a few like that. And now if we take that instrumented context and use it in here, we could run this test and see what happens. Okay, we had a begin, a commit, a begin, a begin, a commit, commit. Okay, it's really quite confusing. Let's whittle these down to not have pairs for a start. Okay, I think we'll get rid of the start ones. So that can go, and that can go. And we haven't seen your rollbacks, but we'll get rid of that anyway. And then this is begin, and this is commit, and this is rollback. And now before we go on, let's just see what we kind of expect. we're clearing the database here, but in a non-instrumented transaction. But then we're doing fixture init, and the fixture is using our instrumented context. So this init, which saves, is going to have a transaction of its own. So I think we'll put a little bit of debug in here if we say println fixture init, and then we'll go to here and we'll say, in here we'll say println delete, and then this is before load, and this in here is after load, because we're loading in this stock list call here, that in transaction. Okay, that might be enough to be going on with. Let's run. Okay, here we go. Now I didn't put the debug in for it, but I think this last begin and commit is going to be the check that we have here, where we load the stock list in our assert equals. So that leaves us with this little section here, which won't highlight for some reason. But the fact that we have 2 begins and 2 commits suggests to me that we're starting 2 transactions, one inside the other. Whereas what we actually wanted was that the nested thing should happen inside the top level transaction. A little bit of research comes up with this article on the Duke blog. And indeed it says here that propagation nested is the default in Duke. And nested means that we can start one transaction within another and roll back the inner one if things fail. It's a really nice behavior, but it's not what we want here. We want to piggyback on the first transaction, at least in this case. Pulling on this thread, it looks like the issue is that we are creating a DB-items with this DSL context. But when we say in transaction, we are unconditionally saying, let's take the DSL context that we were passed in the first place, and we'll call this transaction result block, and that always creates a nested transaction. So we're going to have to find a way of seeing whether we are already in a transaction and not starting one, if that's what we actually want to do. That looks like quite a bit of work, so a good place to break, and we can work out how to do that in the next episode. Before we go, let's just review the session. At the beginning, as with last week, I really should have checked in my work in progress before addressing the remaining to-do. The code was in the state of passing the tests and being deployable, but not having a check-in made the motion on the shelf much harder than it should have been. Running the DeleteItems test against the database rather than the in-memory items turned out to be much harder than I expected. I suppose this is the reason we use in-memory data in the first place, but had I known the problems I was going to face, then I think I would have written a fresh test to concentrate on the transaction behavior rather than butchering a working test. That said, it did expose a bug in our in-memory items, that it persisted prices, that I think would have bitten us sooner or later, so we can be thankful we found it before it became too entrenched. And that leads to the question of whether we should be differentiating between priced and unpriced items in our type system. That would take work to implement, and we may not see the benefit, but my gut feel is that we should do it, maybe next week. Or maybe we should push and try to finally get our delete running in a single transaction. In these cases, I'll often decide what to do on the day, depending on which I feel would make me most happy or least stressed. So if you aren't already, then please subscribe in order to find out which way this goes in the next episode. And if you've enjoyed this, then I think you'll enjoy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.